Yes, good afternoon, guys. Welcome to the third lecture series of logarithmic function. So, in today's lecture, we will be doing the problems based on logarithm function. Now, let us discuss few problems on logarithm functions. Now, see, the first problem is something like this. If x is equals to log base 2 of a and y is equals to log base 3 of 2a and z is log base 4a of 3a. The question is, prove that xyz plus 1 is equals to 2yz. Now the solution is like this. Now x into y into z is log base 2 of a into log base 3a of 2a into log base 4a of 3a. Now guys, try to observe. Here is 2a, here is 2. So can we use chain rule? So it is coming out to be log base 3 of a into log base 4a of 3a. Now again using the chain rule property. What about this? It is nothing but log base 4a of a. Okay. Now what is xyz plus 1? Can we write this as log base 4a of a plus 1? And we can write this as log base 4a of a plus log base 4a of 4a. Now by property of log, it is log uh, base 4a of 4a square. We can write further log base 4a of 2a whole square. What is that? Can we write this as 2 times of log base 4a of 2a? Now can we write this as 2 log base 3a of 2a into log base 4a of 3a by chain rule. Now what is this? This is y, this is z, so this is 2yz. So that's what we want to prove, guys. So that proves this part. I hope you understood the solution part. Now let us discuss one more problem. The problem is, if my a is log 2, b is log 3 and c is log 7. Now no base is given here. When no base is given, we always take base 10, but let us see what is the problem. And 6 raised to power x is equal to 7 raised to power x plus 4. The question is then find x. We have to find x. Now let us make use of this given condition. Can we rewrite this as 2 into 3 raised to power x, which is equal to 7 raised to power x plus 4. Now uh, can we write this as uh, if I take log both sides, it is log 7 raised to power x plus 4. It is turning out to be x log 2 into 3 x plus 4 log 7. Can we write this as x log 2 x log 3. Now this is nothing but x log 7 plus 4 times of log 7. Now can we write this as, if I shift this term to the LHS, x of log 2 plus log 3 minus log 7 is 4 times of log 7. Now we have the naming for them. This is A, this is B, and this is C, and this is again C. So what we have obtained, x is equal to 4c upon A plus B minus C. So that is the value of x, guys. So it is not so difficult to tell. Now we have another question. The question is something like this. If 5 raised to power x is equal to 0.5 raised to power y is equals to 1000, then find the value of 1 upon x upon 1 upon y. We have to find the value of this. Now see, the solution comes like this. 5 raised to power x is 1000. Okay. Now, if by definition of log, can we write this as log base 5 of 1000 is equals to x. Okay. Now another thing, 0.5 raised to power y is also equals to 1000. Now again by definition of log, we can write log base 0.5 of 1000 is equals to y. Okay. Now we have to find the value of 1 over x minus 1 over y. Can we write this as 1 over log base 5 of 1000 minus 1 over log of 1000. Now guys, by reciprocal formula, it is turning out to be log base 1000 of 5 minus log base 1000 of 0.5. By property of log, it is log base 1000 of 5 upon 0.5. Okay. Can we write this as 1000 and it is turning out to be 10. Now can we write this as log base 10 raised to power 3 of 10, and this is 1 by 3 of log base 10 of 10. So my answer is 1 by 3. So that's a solution of the problem, guys. It is not so difficult, but the only thing is that you have to apply the given condition in the well-defined manner. Now we have another problem. The question is something like this. If log base 2 of a upon 2 is equals to log base 3 of b upon 3 is equals to log base 4 of c upon 4, and we have given a raised to power 1 by 2, b raised to power 1 by 3, c raised to power 1 by 4 is equal to 24. Then the question is, find the values of a, b and c. We have to find this value. Now how to proceed this problem? The important thing is that when these three ratios are equal, they are proportional, they must be equal to some constant. So let us assume that let log base 2 of a upon 2, log base 3 of b upon 3, log base 4 of c upon 4 must be equal to some lambda. Now log base 2 of a is equals to 2 lambda. Now by definition of log, can we write my a is equals to 2 raised to power 2 lambda. Similarly, I can say that log base 3 of b is equal to 3 lambda. So my b is equals to 3 raised to power 3 lambda. And by same argument, log base 4 of c is equal to 4 lambda. Can we write my c is 4 raised to power 4 lambda. Now we have this condition. A raised to power half, sorry, here the power is 2 lambda. A raised to power half, b raised to power 1 by 3 is equals to 24. Now let us try to find it. Now we have a is 2 raised to power 2 lambda and my b is 3 raised to power 3 lambda into 1/3 and 4 raised to power 4 lambda raised to power 1 by 4 is equals to 24. Now if I start solving it, now what I going to get? 2 raised to power lambda, 3 raised to power lambda into 4 raised to power lambda is equals to 24. Now guys, if I want to write the prime factorization of this, 2 into 3 into 4. Now it is not exactly prime factorization, but the factorization part, then this will imply my lambda is 1. If lambda is 1, then a is 2 raised to power 2, that is 4. B is 3 raised to power 3. What is that? 27. And C is 4 raised to power 4. So this way you can get the answer. So it's not so difficult problem. Again I'm saying, just apply the condition in the well-defined manner. Then only you can get the solution of such type of problems. This problem looks like some ridiculous problem, but by applying the condition in the well-defined manner, you can get the answer. Okay. We have another question. If my a is log base 24 of 12, my b is log base 36 of 24, my c is log base 48 of 36. The question is, prove that ABC is equals to twice BC minus 1. Now in order to find the solution of this problem, guys, first I will consider what exactly comes out to be ABC. Let us start solving it. That is, ABC is equals to log base 24 of 12 multiplied by log base 36 of 24 multiplied by log base 48 of 36. Now if you observe the chain rule, this and this coincide, so they will neutralize, and it is turning out to be log base 36 of 12 log base 48 of 36. Again by chain rule, these two things neutralizes. It is coming out to be log base 48 of 12. Okay. Now let us consider that how we are going to simplify this expression. Okay. Now if I ask you what comes out to be BC, what is B into C? Now see, this is B and this is C. This is nothing but log base 48 of 24 by chain rule. Now, see, uh, what about if I take their subtraction part, ABC minus BC? It is coming out to be log base 48 of 12 minus log base 48 of 24. Can we write this as log base 48 of 12 by 24? That is nothing but log base 48 of 1 by 2. Okay. Now if I ask you what is ABC minus 2BC? Now this is nothing but I would say uh, log base 48 of 12 minus 2 times of log base 48 of 24. Yes, like this. Can we write this as log base 48 of 12 minus log base 48 of 24 square? This is log base 48 of 12 by 24 square. If I simplify it, now see what is going to happen. It is nothing but log base 48 of 1 by 48. You start cancelling out it, because you can write 24 into 24 like this, which is equals to log base 48 of 1 and 48 of 48. This is 0, this is minus 1. So ABC minus 2BC equals to minus 1. So ABC is equal to 2BC minus 1. So that proves the question, guys. So this way we have proved this question. So you can easily see that it is not so difficult. Again, I'm saying it is not so difficult. Now, one more problem. The problem is something like this. 1 upon, we have to sum the series log base 2 of n plus 1 upon log base 3 of n plus 1 upon log base 4 of n till 1 upon log base 43 of n. Now, it is an easy problem. Can we write this as by reciprocal formula log base n of 2, n of 3, n of 4, n of 43, which is equal to log base n of 2 into 3 into 4. We can also write this. So my answer is log base n of 43 factorial. That is the sum of the series, guys. So it's not a serious problem. This can be solved very, you can say that in the refined manner. It's not so difficult. You can easily solve this type of question. Now we have another problem. Now, the question is, if 1 over log base 2 of a plus 1 over log base 4 of a till 1 upon log base 2 raised to power n of a is equals to n into n plus 1 over lambda. The question is, then find lambda. Now see how we are going to find it. See, uh, again by reciprocal formula, it is log base a of 2, log base a of 4 can be written as 2 raised to power 2 till log base a of 2 raised to power n. By property of log, this can be written as log base a of 2 into 2 square into 2 cube till 2 to the power n. This is nothing but log base a of 2 raised to power 1 plus 3 plus n. Now, this is the sum of first n natural numbers. This is log base a of 2 raised to power n into n plus 1 by 2. This is coming out to be n into n plus 1 by 2 log base a of 2, and which is further equals to n into n plus 1 over lambda. This will get cancelled. So 1 by 2 into log base a of 2 is 1 over lambda. Now what is my lambda? My lambda is 2 over log base 2 of a. If I want to solve it further, 2 log base a of 2. I can write this as log base a of 4 as well. So that is the answer, guys. I hope guys you like this video. So I will be keep posting uh, the problems based on logarithm. So we require 2-3 more lectures, because I'm solving say around 6 to 7 problem per lecture, so that you can understand it, the concept, and you can well remember these formulas. So till then guys, bye. So see you in the next video. So if you like my video, so please keep subscribing and follow me. Okay, bye then.